I will be showing you how to complete this problem. It says carbon is reacted with hydrogen gas to produce carbon tetrahydride. If I react 755 grams of carbon, how many grams of hydrogen gas should be needed to react completely? Now, first we got to do the skeleton equation, which consists of carbon plus hydrogen gas, and it yields carbon tetrahydride. So it's carbon tetrahydride. So now we have to balance it, which means we have to take each element and make it so that both sides are equal to each other. So carbon has one element on each side, one atom on each side, my bad. And then hydrogen has 2 on this side, but 4 over here. Now we can multiply this, we can add a 2 as our coefficient to multiply this by 2 in order to help us get 4. So these two are equal now. Okay, so now that we have our equation that we can draw our ratios from later on, we can start with the actual problem. Now, carbon is reacted with carbon has 755 grams to begin with. So let's stretch this out because we don't know how long. And we're trying to get to the grams of hydrogen gas that we need. So we need 1 mole of carbon in order to cancel out this, but we need to find the molar mass of carbon, and so that way this can cancel. So molar mass of carbon is 12.01 grams according to the periodic table. So these two will cancel out. Next, we will use the ratio that we've gotten from the balanced equation in order to shift into hydrogen. So for every 1 mole of carbon, you have 2 moles of hydrogen gas. Now, these two cancel, which means we are now in hydrogen. We're within hydrogen gas now. We're no longer dealing with carbon. So now what we have to do is, in order for this to cancel, we have to find how much a mole of carbon is. Oh no, not carbon, mole of hydrogen gas. And it would be 2016 grams hydrogen 2. Now these two cancel. Okay, pause it. Okay. Now we have to multiply 755 times 2 times 2.016. And then we divide that by 12.01, because 12.01 times 1 times 1 is still 12.01. Now our answer is really big, but we have to use our significant figures, which for multiplication you use for multiplication and division you use however many is the least. This one has 3. This one has 4. And this one has 5. The rest don't count simply because they are counting numbers and the number of significant figures with them could go on and on. So our smallest number of significant figures is 3. So we are going to round this answer to 3, which would give us 253 grams of hydrogen gas.